Now, as we go on to our last topic of Chapter 4, it is Section 5, Systems of Linear Equations and Problem Solving. So in these, what we're going to do is to have various word problems in our textbook. And I'm not going to write all of the example out, but I'll sort of summarize. So example 1 is predicting when we're going to have equal consumption of red meat and poultry. Now, this is the equation they've come up through analysis and probably doing point slope form from Chapter 3. They came up with this equation for the use of poultry in the American population. And they came up with this equation, and again it's in slope-intercept form, for red meat. Now again, what we're doing here is trying to give you a strategy for doing these things. So if we wanted to make perhaps a little graph of what's going on, and there is one in the textbook. For poultry, we notice this is our y-intercept. And let's say it's about here where you have 68. And this is our y-intercept for red meat, which is up here for about 113. And since this is negative slope, we're going to suggest that this line is going down. And since this is positive slope, we're going to suggest that this line is going up. And that's what is shown in the chart graph in our textbook. So we're looking for a time where these are going to intersect, because down here we have years. So again, we don't know when the graph starts. Let's see, it starts in the year 2000. And we have data up to like 2011 or so. But where in the future will these lines intersect? And what technique can we use to solve these equations? Now you might have noticed something, that this is y and this is y. So in a sense, this equals this. And that will be our equation. So we're going to say that this equation equals this equation, which is what I have here. Y equals y. So I got rid of my decimals. And by the way, this is a little different way than the book does. And that's okay, because there are different ways to solve it. And I'm going to add 56x to both sides, and I get 132x. I'm going to subtract this from both sides, and I get this. I'm going to divide both sides by 132, and I get this. So now what we have to do is determine, well, what's the answer? When will the consumption of red meat and poultry coincide? And actually, this is real data, by the way. We're not making this up. And we got x equals 34, but what does that mean? Well, remember, this is 34 years, and that's approximation, rounding it off to the nearest whole year. So remember, this was 2011, but it started in 2000. So if it starts in 2000, then out here, and I didn't make these very well, just to show you what's sort of going on, it'll be 2034 where they actually intersect. And once again, we solved it by having two equations, y equals something, y equals something. Whenever you have that, just equal them to each other and solve it. Now the book uses elimination, which I think is kind of foolish because it's so much easier doing it this way. Now, one of the things for this section, section 5, that I didn't stress enough is the protocol, that is the modus operandi, or the steps you take to solve problems. I think we mentioned this in an earlier chapter, but a review is probably good. And that is, you read the question a number of times. Now, because I didn't put the other question up, that's why I didn't stress it. But here, read this. Find two numbers whose sum is 37 and whose difference is 21. So the point being, this one is sort of easy, but you may have to read it again to try to understand what they're saying. So here it's find two numbers, well, x and y, whose sum is 37 and whose difference is 21. So, you're never going to get one easier than that, because what system would you use to solve it? Wow, look at these, are going to add right out. So you get 2x equals 58. X is going to equal, just divide both sides by 2. Here this is going to be 29. So if x is 29, what is y? Well, you just put the 29 there, plus y equals 37, and you're going to subtract 29 from both sides, and you get 8. Now, check it out. 29 plus 8 is 37. 29 minus 8 is 21. And how did we do it? Well, we use systems of linear equations, and in this case we use the elimination method. Now, they're getting a little more complicated, but that's good, because you want to build up from easy to more challenging. So again, we're going to read it carefully. The first number is 4 less than the second number. In fact, let's just focus on that. So how many numbers do we have? Well, we have 2 numbers. So the first number, which will be x, is, we just translate into equal sign, 4 less than the second number. Well, the second number will be y, and it's going to be 4 less. So again, the first number is 4 less than the second number. So notice what we're doing. We are defining x as the first number, y as the second number. Then reading the next part, 4 times the first number. Well, 4 times the first number is 6 more than twice the second number. Well, the second number is y, so twice y plus 6. So 4 times the first number is 6 more than twice the second number. There's our equations. So you might say, well, what method would I use then after I set it up? Well, notice you have solve for x here. This is what x is. So we're going to put that value right there and rewrite it as 4 times whatever the x is, y minus 4 equals 2y plus 6. We now have an equation with just one letter variable. We're going to distribute 4y minus 16 equals 2y plus 6. I want to keep my y's positive, so I'm going to bring that over. This is going to be a 2y over here. I'm going to bring my negative 16 over, and that gives me a positive 16, so that's going to be 22. So I get then y is 11. Well, if y is 11, what will x be? I can put that 11 right there. 11 minus 4 is 7. So my ordered pair then would be 7, 11. Oh, those are sort of like lucky numbers, aren't they? In example 4, I believe, we're going to solve problems about prices. Now again, I'm not going to write it all out, but in Circus Olay, if you had 4 adult tickets and 2 children's tickets, the total cost would be $3.74. Now, if you had 2 adult tickets and 3 children's tickets, the price would be $2.85. So, in a sense, we have a system of linear equations for A and C. You can think of it as X and Y. Could have done it that way. I like the idea of being able to use A for adults, C for children. And we're going to solve it. Now notice nothing cancels out. And there's no letter by itself, so we can't use substitution. So the method here is to modify these particular equations. Okay, so again, part of this is artisan. You've got to kind of think about it. I will modify this first equation by multiplying each term by -3, and this equation by multiplying each term by 2. Notice what I'm shooting for is I'm going to get the c's to cancel out. So this is a -12a, -6c, a -1122. This is 4a, 6c, what I'm looking for, and then 550. Now as you do these, just take your time and check your signs. Again, you're not going to get that many examples to do, but you need to get them correct. So now these cancel out. I end up with an 8a, and then that equals, notice the negative, a -552. Well, I'm going to divide both sides by a -8, so I end up with an A. And I have the cost then of the adult tickets for Circus Olay is $69. For the child's ticket, once I have the 69, I put that into, I guess I'm using the second equation, and then I will solve for C. Multiply, get rid of the parenthesis, transpose, divide by 3. So the child's ticket is $49. Now if you put these numbers into either equation originally, that will make it true. So remember, the interpretation is the adult's cost for a ticket is $69, while the child's ticket is $49. Now in your textbook, they give you 2 pages of background where they describe techniques first in setting up the equations, then in solving. So we've cut it down a lot here. Now, this next one, I'll describe the problem to you. We have 2 cars that are leaving a certain point. One is driving east, one is driving west. And eventually they're going to be, in 3 hours' time, 297 miles apart. Now, one car is driving 5 miles an hour faster than the other. What is this rate of speed? And for this, we're going to use the formula distance equals rate times time. So we know the distance is 297. We know the rate of one car is R times 3 hours. We know the other rate times time will be 3 hours times R plus 5. And there is our equation. Now, if I looked at the textbook a little more closely, and we're on page 286, I would have seen they did it a little differently. Again, there are different ways to do it. And they're using 2, where this is the rate of one, this is the rate of the other, time times this is that, and then x is equal, one rate is 5 miles more than the other. Again, you could do it this way. You're going to substitute this for one of the x's here, and you get an equation in 5. They work out in either way. So, solving this, we could use substitution. And notice the equation I get. 3 times, we're going to put the x as y plus 5. 3 times y plus 5 plus 3y equals that. Well, can you see that? 3 times y and 3 times y plus 5. So the thing is, this is how we would have done it in chapter 2 when we were working on equations with one variable. But sometimes the use of 2 variables makes it a little easier. So there's more than one way to do it. And here, if we get y is 47, we just have to add 5 to the y to get 52. Those are the rates of the car. Now, we did some mixture problems back in chapter 2. So looking at this in general, without reading all the details, again, covers 3 pages in your textbook. We need 70 liters of a 50% solution. And this chemist has, I don't need to write that twice, a 30% solution and an 80% solution. How much would she need of each is our question. So we know we're going to define the x as the 30%, the y as the 80%. And we know then that x plus y equals 70. So what would our equation be? Well, 30% of x, which is this, plus 80% of y is going to equal 50% of 70. And this is the marvel of algebra. By coming up with this equation and then grinding it out, you end up with an answer. Now notice this is the key here. X plus y equals 70. So we're going to solve for x. So x is 70 minus y. That's very similar to what we did in chapter 2. Now I'm going to get rid of the decimals and then substitute my x with this value, distribute, collect like terms, then divide both sides by 50. I get y equals 28. So if y is 28, what do I need for x? Well, I subtract the 28 from the 70, and I get 42. Now, remember, this isn't really answers yet, because we haven't interpreted this. But now we can. We will need 42 liters of the 30% and 28 liters of the 80% to make a 50% mixture that total 70 liters. There's the work, and there's the strategy. Again, we could have done it with one variable, but they're showing it here with two. All right, in example 7, we're going to take a look at solving problems with cost and revenue functions. Now, this is rather reasonable. You're in business, and let's say you already have a building and electricity and lights, but you want to produce a stationary package. And for this, you're going to need special equipment. So there's going to be a capital cost for this equipment of $3,000. And as you make the unit, the electricity and lights and overhead for that, plus the paper, it costs $3 to make an individual stationary set and wrap it up for sale. But you will sell these for $5.50. So what you're wondering here is, what is the break-even point? So this is going to be your revenue function, and this is going to be your cost function. Notice this is your $3,000 over here, and $3 per item. So we have to set up those equations in a moment. But eventually, as you sell things, because you're making more than what it costs to produce one, you're going to have a point of intersection. So at that point of intersection of these two functions, that is your break-even point. So, looking over here, what's the cost? Well, we say the cost is going to be $3, or we can take away the decimal points, we don't need those, for every item of stationery you produce. Plus, there's a startup cost of the $3,000 for equipment. So this is your cost function. Now here, this is your revenue function. Every time you sell one of these packets, you're going to earn $5.50. Now I don't know if you remember our first one about the red meat and the poultry, where we said this was like y equals something, y equals something. Again, I think the easiest way to do this is to use the system of y equals y here. I'm thinking of function. So it's going to be 5.50x equals 3x plus 3,000. Okay? So I'm going to subtract 3x from both sides, and that's easy. That's 2.5x equals 3,000. And now divide both sides by 2.50. I didn't get rid of the decimals because there were so few. So this is going to be 3,000 divided by 2.5. And I end up with 1,200. But again, 1,200 is a number. What's the interpretation? What's the answer statement? That when the company sells 1,200 stationary packets, it will be the break-even point. And that's what they're looking for here. Okay, going on now to our last problem of Chapter 4 is example 9, where we're going to find angles. Angles of a triangle. Now the key here is, and I think most of you know this, that the angles of a triangle equal 180. So often a picture too helps you to organize your data. Now, as we read through the problem, we find that there is a smallest angle. So that smallest angle looks like this one up here. We'll call that one S. We can name it X or whatever. Now the largest angle is 80 degrees more than the smallest. So we're going to have the smallest plus 80 degrees. And then the other angle, and I may have these a little bit off, but symbolically, is 10 more than the smallest. So here's the smallest plus 10. Now that I look at it, maybe this is the smallest, but that's okay. Now, what do? Well, you just sum all of your angles. And let me mention, the textbook does it a little different way, but this is a good way too. So then we have 3s, as we collect like terms, plus 90 equals 180. We're going to subtract 90 from both sides, and we get 3s equals 90. So s equals 30. So our smallest is 30, this is 40, and this is going to be 110. And when we add all these up, they should add up to 180, and they do. Okay, well this completes Chapter 4. Again, stay up to date with your practice and quiz me's. We'll be having a test day on Chapter 4 at the appropriate time. And you want to be up to date with it. Again, keep bringing your work into Math Zone as you have questions. This is what we're here for, to help. And good luck.